All right, this is the end of module review. The first question, we are going to graph the system of equations here. So for the first one, I have the slope here of -2/1 and the y-intercept of 5 or 0, 5. And for this one, I am going to solve it. So I'm going to subtract x from both sides. And I'm going to get y equals -x plus 2. So for this one then, my slope would be -1/1, and my y-intercept would be, hold on. I'm going to change this and put it over here. There's no point in making everything scrunched up. So my slope then for that one would be -1/1, and my y-intercept would be 2 or 0, 2. So putting them in, I've got 5, and I have -2, so down 2/1, down 2/1, labeling my y and x axes. So now we've got my first line here. Remember to go through the axes. So here I've got y equals -2x plus 5. And the other one is at 2. And we go down 1 and over 1, down 1 and over 1, down 1 and over 1, down 1 and over 1. Okay. And that one should be this way here. And where it crosses, and I apologize, let me redo this the proper way. So 5 here, 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 and down 2/1 here. Okay. So actually it's going through this point right here. Okay. So we have 3 and -1 is our solution. Okay, 3, -1 is our solution. Let me label our, okay. So here we've got y equals -2x plus 5. Substituting in, we get -1 equals -2 times 3 plus 5. So -1 equals -6 plus 5. -1 equals -1, and that's a check. All right, now to check the other one, we get x plus y equals 2. So we have 3 plus -1 equals 2, and 2 equals 2, and that's a check. Okay, so next, all right, determine the type of solution without solving. The first one is, the second is a multiple of the first, so we have infinite. Many. The second one, we have different slopes, so we have one solution. And the last one, if you look at our slopes here, they are the same, different y-intercepts. So they are parallel, so no solution. All right, next, excuse me, we need to solve these algebraically. Okay, So let's take care of the first one. We're going to substitute y into our top equation. So we have 3x plus 2 times negative 2x plus 2 equals 6. So we have 3x plus, I'm sorry, minus 4x plus 4 equals 6. So now we have negative x plus 4 equals 6. So subtract 4 from both sides. So I have negative x equals 2. Divide both sides by negative 1. X equals negative 2. So now y equals negative 2x plus 2. So negative 2 times negative 2 plus 2. So 4 plus 2 equals 6. So y equals 6. So our solution is negative 2, comma 6. So our check is 3x plus 2y equals 6, or 3 times negative 2 plus 2 times 6 equals 6. So negative 6 plus 12 equals 6, or 6 equals 6, and that works. Excuse me. We also have y equals negative 2x plus 2, or 6 equals negative 2 times negative 2 plus 2. 6 equals 4 plus 2. 6 equals 6, and that also checks. Okay. Our next question, we have we will solve this by elimination. I am going to multiply the top by negative 2. So we have negative 6x minus 2y equals 6. 4x plus 2y equals 14. These are eliminated, so now I have negative 2x equals 20. Divide both sides by negative 2. I have x equals negative 10. So substituting that in, for x plus 2y equals 14. 4 times negative 10 plus 2y equals 14. Negative 40 plus 2y equals 14. I'm going to add 40 to both sides. I get 2y equals 54. Divide both sides by 2. Y equals 17. So we have I knew something was wrong. Sorry, guys. I apologize. Let me try that one again. I knew those numbers were way too high. This is a 6, not a negative. So let's try that one again, shall we? So now this is 10x. I apologize. Equals 20. Remember, that's a positive. So now divide both sides by 10. That's x equals 2. So now let's go back up here. So I've got 4x plus 2y equals 14. So 4 times 2 plus 2y equals 14. So 8 plus 2y equals 14. Subtract 8 from both sides. 2y equals 6. Divide both sides by 2. Y equals 3. So our solution is 2, 3. So to check that answer then is negative 3x plus y equals negative 3. Negative 3 times 2 plus 3 equals negative 3. Negative 6 plus 3 equals negative 3. Negative 3 equals negative 3. That checks. We have 4x plus 2y equals 14. So we have 4 times 2 plus 2 times 3 equals 14. So we have 8 plus 6 equals 14. 14 equals 14. And that checks. Okay? So next. Here we have, given the equation, 3x plus 9y equals negative 8, write a second linear equation to create a system that has exactly one solution. Okay, well, I'm going to rewrite this in y equals mx plus b form. Okay, so we have 3x plus 9y equals negative 8. Subtract 3x. So 9y equals negative 3x minus 8. Divide by 9. And I have y equals negative 1/3 x minus 8 over 9. So I could write 2x plus y equals 10. Okay, explain my reasoning. The slopes. Oh, hang on. One solution because the slopes are different. Okay. Now, no solution, so I could write y equals negative 1/3 x plus 1. No solution because the slopes are the same and the y-intercepts are different. And the last one infinitely many solutions because it is a multiple of the first by 3. Okay. Now the next one. What does the graph of the following system look like? Let's see. Well, they are the same equation. So one equation will lie on top of the other. All right, what type of solution would it have? Infinitely many. If I multiply the top by 2, all I have to do then is add them, and they all equal 0. So 0 equals 0, and therefore infinitely many solutions. Okay, next. We did this one in class. Students sold 275 tickets for the fundraiser at school. Some tickets were sold. Some tickets are sold for children at a cost of $3, while the rest are adult tickets that cost $5. If the total value of all tickets sold was $1,025, how many of each type of ticket was sold? You must solve it algebraically. Well, we said let X equal the number of children's tickets and let Y equal the number of adult tickets. And then we said, well, 275 tickets were sold. So we said let X plus Y equal the 275. And if the children's cost 3, while the adults cost 5, and all the tickets sold were 1,025, we said 3X plus 5Y equals 1,025. So now we can multiply the top by -3. So we have -3X minus 3Y equals -275. So 3X plus 5Y equals 1,025. So using our calculator, we have 2Y equaling 750. Dividing both sides by 2. Y equals 375. So putting that in, which that cannot be right. Oh, I forgot to multiply this top one by 3. Oh, Mrs. Smythe. Sorry, 825. And this should be 200 divided by 2, so y equals 100. That makes more sense. So now x plus y equals 275. X plus 100 equals 275 minus 100. X equals 175. So there are 175 children's tickets. And 100 adult tickets. Okay? Next. What is the y-intercept for line 1? Y-intercept is 4. 0, 4. For line 2 is 2. For 0, 2. The system of equations would be y equals, for this one, for line 1, is down 2 and over 4. 1, 2, and 1, 2, 3, 4. So it would be down 2 and 4, which would be negative 1/2. So we could write for line 1 would be negative 1/2 x plus 4. For line 2, it's up 2 over 2. So 2 over 2 or 1. So for line 2 would be y equals x plus 2. Just use the graph to estimate the solution. And I would estimate it at 1 1/3 and 3 1/3. That's what I would estimate it at. Okay. So now it says to solve the system of equations. And for, let's see, did I do that? I think I did. Okay. All right, so here we go. So we have y equals negative 1/2 x plus 4. Y equals x plus 2. So x plus 2 equals negative 1/2 x plus 4. So 1/2 x, 1/2 x. So 3 over 2 x plus 2 equals 4. Subtract 2 from both sides. So 3 over 2x equals 2. All right, so multiply 2 over 3 and 2 over 3. So x equals 4/3. So let's replace it with over here. So x plus 2. So y equals 4 over 3 plus, let's change this 2 to a fraction. So 2 times 3 is 6 over 3. So y equals 10 over 3. So the solution is 4 over 3, 10 over 3. And substituting that in, we've got y equals x plus 2. So 10 over 3 equals 4 over 3 plus 2. 10 over 3 equals 4 over 3 plus 6 over 3. 10 over 3 equals 10 over 3. And that equals. The other equation is y equals negative 1/2 x plus 4. So we've got 10 over 3 equals negative 1/2 times 4 over 3. Again, I'm going to change this. So we've got plus 12 over 3. This cancels to 2 here. So I have 10 over 3 equals negative 2 over 3 plus 12 over 3. 10 over 3 equals 10 over 3, and they both check. Okay, next. Oh, we are done. Okay, that is it for the review, ladies and gentlemen. Okay, we are done.